Hi, Assalamualaikum warahmatullahi wabarakatuh. So I'm going to introduce myself first. My name is Wan Daniel Faruqi bin Roslan and my metric number is CN220090. So for today's video, we're going to present to you the technology design project for this semester, which is the smart garment hanger. So without wasting any more time, let's move on to the introduction. So as you can see, technological innovation consistently aims to improve even the most modern aspect of our daily routines in the ever-changing landscape in modern living. So the introduction of the smart garment hanger, which combines the state of the art technology with the essential need to preserve clean clothing, represent a major advancement in the care of clothing. This clever solution offers a seamless merger of convenience, efficiency, and creativity. It not only simplifies the tedious task of hanging clothing, but also redefines the entire process. Let's move on to the next slide. So as you can see in the slide, the objective of our project is to design a controlling system automatic hanger using Arduino Uno. Next is to develop a hardware for an automation smart hanger. And the last one is to evaluate the performance of the smart garment hanger. Let's move on to the next slide. My friend will explain to you about the literature review. Thank you.
Hello, my name is Aznar Yusuf, and for my part is literature view. For microcontroller, we use Arduino Uno. The Arduino Uno is a popular microcontroller board that is part of the Arduino open source hardware platform. Here are some key features and information about the Arduino Uno. The Arduino Uno is based on AT 32 328V microcontroller, which is a versatile and widely used 8-bit AVR microcontroller. Next is a retractable cloth hanger, which is we use the stainless steel one. A retractable cloth hanger made of stainless steel is a practical and durable solution for hanging drying clothes. This type of hanger typically offers space saving benefit and is suitable for both indoor and outdoor use. Then we use AC/DC 12-volt converter. An AC/DC converter, also known as a rectifier, is a device that transforms alternating current, which is AC, into a direct current DC. Then we use Arduino humidity sensor. The humidity sensor for Arduino Nano is a device that measures the moisture content in the surrounding air and provides this information to an Arduino Uno. Okay, and we also use 12-volt actuator motor. 12-volt linear actuator is an electromechanical device that converts electrical energy into a linear motion. It is designed to provide precise and controlled linear displacement when a 12-volt direct current power source is applied. Linear actuators find application in various industries and systems, ranging from robotic and automotive to automotive. And for the last part, we use relay. A relay is an electromechanical or solid-state switch that uses an electrical signal to control the opening or closing of one or more set of contacts. Relays are widely used in electronic and electrical systems to control high-power devices or circuits with a low power signal. They serve as an interface between a low voltage or low voltage control circuit, such as that of a microcontroller or sensor, and a higher voltage power circuit. For meteorology, the creation of a smart garment hanger is evidence that even the most basic elements of our daily routines have the capacity to revolutionize our life in the quest of incorporate technology innovation, an organized approach that manages the nexus of technology, user experience, and functionality is the methodology used to realize this objective. A deep comprehension of user need and goal form the basic of the process. Survey, interviews, and usability studies offer priceless insight into the difficulties people have organized their wardrobes and what they want to get out of a smart garment hanger. The basic of developing a solution that easily fits into user life is laid at this phase. A true market analysis is essential in the always changing world of smart home solutions. When the power supply is turned on, the humidity sensor will detect the normal reading of the weather, and then the solenoid will extend the root of the hanger open. When the humidity sensor detects any change of the weather humidity, sensor will send a signal to the Arduino, which will notify the solenoid to retract the root of the hanger, which is closed. If the humidity of the weather is back to normal, the root of the hanger will extend again. Okay, and for the project flowchart, when we start, first we do a meeting, discussion, and a brainstorming. Then we listing pros and cons of the project. Then we finalizing project selection. Then, if it approved, we are going to creating of the whole project. We are if it is not approved, we are going back to the listing pros and cons of the project. After creating a draft of project, we listing all the necessary material. Then we create a prototype and testing. If it's passed, we are going to the refine and upgrade the project. If no, we are going to create again the prototype and testing. Then we do a documentation. And then we presentation. That's all for the project flowchart.
Alright, up next is our circuit diagram. As you can see, there are three main components for our project, which is the HT11 sensor, Arduino Uno, and relays. For the inputs, we'll be using the DHT11, which relay the information to the Arduino, which act as the processing unit, which relays the input into the relays as an output. This circuit is connected in a specific way so it can run properly with our program, which I will explain it later. Alright, for our software development, we'll be using Arduino IDE since we'll be using Arduino Uno. So on the first diagram, first we need to include the DHT library, and then we will assign each pin at which the each component is connected on the Arduino. Alright, on the void setup is where we assign each component whether it's input or output. On this project, our DHT11 is our input and our relays is our output. Up next is our void loop program. Alright, first we need to activate the DHT11 by using the serial begins, and we assign at which the Arduino need to get the data from. For this project, we'll be using the temperature data from the sensor. After that, we need to write a code using a if else to tell when the relay needs to turn on and when the relay needs to switch off. In this way, we can control the output based on our desired objective. Next is our humidity sensor. So for our humidity sensor, first we need to define the pin where it's connected. After that, we need to define the type of the HT sensor that we be using. Alright, up next is the voice setup. Also, at the voice setup, we need to tell the Arduino to activate the DHT11 to start it to record any data. Alright, so on the void loop, we need to tell the Arduino from which what kind of data that we want. So on this project, we want the temperature data. So we'll be using the dht.read data command, and then we will using serial print to display the data that the DHT11 has collected.
So for our 3D layout design, we designed the smart garment hanger using SketchUp Designer from Google. So as you can see from the first picture is the layout we designed. We use this software to create the hardware of the project so that we can measure the proper length for the smart garment hanger and the length of the 12 volt actuators so that we can make sure it fits properly with the stainless steel hanger. So as you can see, the second picture shows the hardware we finished built according the 3D layout design we made and paint. The third picture shows from the side angle, and the last one is from the behind of the project. That's all.
So over here is our result. Right, on the first table, it shows that this project have gone through 4 trials, and from trial 1 until 3, we have found many problems that needs to be addressed when developing this project. Right, not until the fourth trial where we got all the things correct and work as planned. Right, on the second table is the comparison between before troubleshooting and after troubleshooting. Alright, before troubleshooting, the power supply cannot supply a decent DC voltage to the circuit, which affect the overall performance of the circuit. And after troubleshooting, we managed to make the power supply to provide a constant DC voltage at a constant level. Right, up next is the Arduino board. So before troubleshooting, it was found that the Arduino cannot provide a stable output signal to the release module, which make the linear actuator cannot function properly and been cut off mid-operation. So after troubleshooting, the Arduino able to provide a more stable output signal to the relay. Next is the DHT sensor. So before troubleshooting, the DHT sensor has limited range and cannot has low sensitivity. Right, so after troubleshooting, after a couple of adjustment to the sensor, now the DHT sensor able to sense a wider range of temperature and more sensitive to the temperature changes surrounding. Up next is the two channel relay. Before this, the channel relay cannot control the linear actuator reliably because of the signal from the Arduino board. So after troubleshooting, the relay able to control the linear actuator more reliably and more consistently. Right, for the last component is the linear actuator itself. Before troubleshooting, the linear actuator able to run smoothly but cannot move in the direction that is intended to move. But after troubleshooting, the linear actuator works like a charm and can move according to the program.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arifuddin bin Ishaq. Today, I would like to explain about the bill of material that we use in our projects. There is 10 hardware part that we use for our project. First is Arduino Nano, retractable cloth hanger, AC/DC converter 12 volt, 13 amp 3-pin plug top, humidity sensor for Arduino Nano, 12 volt linear actuator, breadboard, jumper wire, motor driver, and lastly is relay. Uh, there are two items that cost very high in our project. First is retractable cloth hanger, and second is 12 volt linear actuator. The 12 volt linear actuator, we must spend the cost about around 151 ringgit 72 cents. Okay, now the last one I would like to explain about the conclusion for our project. In conclusion, by using technology with our daily activities, the smart cloth hanger signifies a revolutionary development in the field of wardrobe management. Users have never before seen convenience and control over their clothes thanks to its integration of sensor, connection, and intelligent features. Equipped with features including intelligent alerts, automated climate-specific adaptation, and real-time garment condition monitoring, the smart clothing hanger is redefining what a hanger is traditionally. In the next project, we can improve our project by putting such as another sensor such as uh, rain sensor, uh, temperature sensors, and other sensors that we can put. That's all from me. Thank you.
Asal tak nak ajak aku tu?